Hey kiddos, we are going to be looking at simplifying fractions, mixed numbers, and improper fractions. There are 5 pages. As always, my expectation, my hope is that you will work on 1 page per class that you attend, as long as I am your only math program. So we start with the greatest common factor, and then we divide both pieces by that. Remember, we need to always make sure that we are in simplest form. So make sure that you can't get it down any further. So for this one, I would divide both by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. The only common factor left at this point is 1. So this is simplest form. For 3, again, I could factor out 1 times 3, and then 9 would be 1 times 9, 3 times 3. They're both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3, 1/3. 7/10. 7 is prime. 10 only has the additional factors of 2 and 5. This is going to be already in simplest form, okay? For 8, though, we can divide these both by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. Down here, 2/3, they're both prime numbers, so the factors are 1 and 2, 1 and 3. The only common factor they have is 1, so this is simplest terms. And then 2, 6 can both be divided by 2. 2 divided by 2 is 1. 6 divided by 2 is 3, 1/3. That's the end of our first page. Please bring any questions that you have with you to class. Jumping right into our second page. 2 and 7 are prime numbers, which means they're both only divisible by 1. That would be their common. This is already in simplest form. 3 and 12, we can divide both of these by 3 and get 1/4. 6 and 36, we can divide both of these by 6 and get 1/6. 4 and 50, we can divide both of these by 2. 4 divided by 2 is 2. 50 divided by 2 is 25. And we always check, is this lowest terms? Yes, because 2 is prime, it only has 1 and 2. 25 is not divisible by 2. Moving down, 6 and 30, we can divide both of these by 6 and get 1/5. 25 and 40, we can divide both of these by 5 and get 5/8. They're not both prime numbers, but 5 does not divide into 8, which means that's lowest terms. That is the end of our second page. If you have questions, please bring them with you to class. Remember, you can always pause this and rewatch if needed. All right, jumping into page 3. We are switching topics here. We are now simplifying mixed numbers using the C method. I tell you to think pizza because we're talking about how many fit in a box. How many boxes do we have and how many extra pieces do we have, right? We also call this the C method because when you look at it, it kind of looks like a letter C. It's almost like you're going backwards, creating a letter C when you do this. So let's take a look, and I'm going to write this a little bit bigger for solving's sake. So we're going to multiply by the bottom, add the top. 300 times 3 is 300. Add 6 is 306. We don't change the denominator because remember, the pizza box is not going to grow, right? It's going to stay exactly the same size. Same thing, multiply by the bottom, add the top. Each box holds 25 pieces. If I have 5 boxes, that means I have 125 pieces. Add that to the 11 pieces that were in their own box, not a whole box, but still there. Keep our denominator, 136 over 25. For this one, multiply by the bottom, add the top. Think of that backwards C. 50 times 2 is 100. Add the 21 is 121. Don't change the denominator, 121 over 50. Multiply by the bottom, add the top. Each of the 4 boxes holds 20 pieces. That means we have 80 in total. Add those to the 3 pieces. We have 83 pieces. Each box would hold 20. 83 over 20. 6 and 2/8. Each box has 8 pieces. We have 6 boxes. 6 times 8 is 48. Add the 2 pieces that are on their own. We have 50 over 8. 7 and 7/10. Multiply and add. 7 times 10 is 70. Add 7 is 77 over 10 is our final. That's the end of this page. If that's as far as you've gotten, please go ahead and stop the recording. Continuing on with, again, simplifying mixed numbers. Remember, we can think of this as the pizza method. How many boxes of pizza do we have and how many pieces are in each box? Or we also have the C method because this looks like a backwards C as we're completing it. So we have 3 and 23 over 100. Multiply by the bottom, add the top. 100 times 3 is 300. Add the loose 23 pieces. We have 323 over 100. Multiply by the bottom, add the top. 5 times 5 is 25. 25, add 3 is 28 over 5 for that one. 2 and 17 over 20. When we do 20 times 2, we get 40. When we add our 17, we get 57 over 20. 5 times 4 is 20, so 50 times 4 is 200. Add 32 is 232 over 50. Down here, if you're not sure of your 25s, think of quarters. If you had 6 quarters, how much money would you have? You would have $1.50. So 150 plus 13 is 163 over 25 is our final. And then 7 and 7/8. 7 times 8 is 56. Add 7. It's going to give you 63 over 8 is our final. All right, love bugs. And then our last page is simplifying our improper fractions. So now that we've made them, can we put them away? So now we're thinking, okay, each box of pizza holds 100 slices. How many slices can I pull out of this? If I have 241, I can pull out 2 full boxes, right? I could also think of this as dividing. So 241 divided by 100, you would get 2 with a remainder of 41. So I'd have 2 full boxes and then 1 box that has 41 slices. Over here, if I skip count by 20s, 20, 40, I can pull out 2. I know my denominator stays the same. If I take out the 40, I'm left with 14. 2 and 14 over 20. If I do 35 divided by 5, this one goes in evenly. I have 7 whole boxes of pizza. 7 whole boxes. Now this one is almost complete, but not quite there. We know 8 times 3 is 24, but we can only pull out 2. That leaves us with 7 out of 8 remaining. So 2 and 7/8. Down here, we can pull out 4 wholes, which is 40. That leaves us with 6 over 10. And then for this one, we can pull out 2 wholes, 25, 50. When we do 73, take away 50. That leaves us with 23 over 25. That brings us to the end of our homework for this week, kiddos. If you have questions, please bring them with you to class. Remember, questions are always welcome. Have a great weekend.